Welcome to this video from Derby Physics Tuition, and I'm working with a student who is applying to the University of Oxford, and as part of the application process students need to sit a paper called the Physics Aptitude test, and this is a type of question you might find in the paper or you might be asked at interview. And this is a ladder problem. Let's get straight into what the problem is. So a ladder is placed against a wall. What shape does the midpoint of the ladder trace as the ladder slides against the wall to the floor? So the ladder is going to slide that way. Okay, slide down the wall, and we're just going to mark the midpoint of the ladder, which is this position here. Okay, and as the ladder slides down, I'm going to mark the midpoint again, which is just there, and the ladder slides further down the wall, so we'll mark the midpoint of the ladder there, and one more there. Now if you follow those points, it looks as if the midpoint is tracing out a circular path if you join those points together, but the point of the question is to prove that it is a circular path. It looks like a circular path, but how can we actually prove that? So here's our ladder, and we're going to say that the ladder has length L, and here's the midpoint of the ladder, and we're going to say that this point has coordinates x, y, and this top half of the ladder will have length L over 2, and the bottom half of the ladder will have length L over 2. Now if this point has coordinates x, y, then this has length x and this has length y. Okay, and this triangle at the bottom will have length x as well and length y. Okay, these two triangles are congruent, so the length of the sides will all be the same. If we place the top triangle over the bottom, it would fit perfectly over it. So those two triangles are congruent. Now if we take this top triangle here and we apply Pythagoras' theorem to it, we get that x squared plus y squared equals L over 2 squared. Okay, now if you think about what we said in the previous slide, it looks like the midpoint of the ladder will sketch out a circle as it slips down the wall, and the equation we've generated here from GCSE maths is the general equation for the equation of a circle. The general equation of a circle is x squared plus y squared equals r squared, and the equation that we've generated here is in that form. Now r stands for the radius of the circle, so basically what we've proved here is that those coordinate points x, y would follow a circular path as the ladder slips down the wall. And if you look at our equation, the equation suggests that the radius of this particular circle will be L over 2, and if you look at this distance here from the point where the ladder meets the ground to the midpoint, that distance there would be L over 2, so that would be the radius of our circle. So a really nice little problem to test your ability to apply maths to this unusual situation, and I really do like this problem. Really nice application of maths to solve it. And if you have any comments or any questions, please do leave them in the comments section below. Thank you very much.